In this lesson, we'll continue our discussion of the spinal cord by taking a look at how these spinal nerves emerge from the spinal cord. So we know from previous lessons that there are 31 pair of spinal nerves that emerge from the spinal cord. Let's take a look at how we divide them up. The first 8 nerves, right, the first 8 pair of nerves that come off the spinal cord are known as the cervical nerves. The next 12 are known as the thoracic nerves. The next 5 are lumbar, 5 sacral, and then 1 coccygeal. Right, so we add these all up. 8 and 12 is 20, 25, 30, 31. Now you may be saying to yourself, all right, I remember when we did the vertebrae, there are only 7 cervical vertebrae. How do we get 8 nerves? It turns out that the first cervical nerve, right, the C1 nerve, emerges above the atlas but below the occiput. So then when we put all the nerves down right through, C7, T1, we end up with an 8th cervical nerve, right? So there are indeed 8 cervical nerves, even though there is only one, um, uh, e- uh, even though there are only 7, excuse me, only 7 cervical vertebrae. So it turns out, if we go back to this picture here for a moment of our spinal cord, there are 2 roots. I'll actually do it over here on the unlabeled side. So again, we've got to identify what's the front of the spinal cord from the back. Right? Always go by this. This deep groove here is the anterior median fissure. So this tells you we have the front. So the spinal nerve is formed by 2 roots. Watch this. One here, and then here is the second one. The second one also has a little bit of a swelling over here. So these 2 roots, this is the anterior root, this is the posterior root. They unite to form the spinal nerve. Right? So I labeled it over here. Right? Here's the anterior root, here's the posterior root, and then they form the spinal nerve. Now, notice the posterior root has a swelling in it. So this is known as a ganglia, right? If you remember from our first lesson on the nervous system, a ganglia is a cluster of cell bodies in the peripheral nervous system. So inside this ganglia are cell bodies, but these are the cell bodies of the neurons that are bringing information into the spinal cord. Remember, this is the posterior horn right here, and we had said in our previous lesson that the posterior horn receives sensory information. That neuron, its cell body, doesn't live in the spinal cord. The cell body lives out over here in the ganglia. So that's why the posterior root has a ganglia. And it's one of the things you can also use to identify the front of the cord from the back of the cord if you don't want to use the anterior median fissure. Right? If you see these the posterior nerve root ganglia here, that tells you this is going to be the more towards the back. Right, so I labeled it on this side. The swelling right here would be the posterior root ganglia. Okay, so again, there's 2 roots, 1, 2, the anterior root and the posterior root. They unite to form the spinal nerve. And again, we know from the previous lesson, the posterior root would have sensory information going in the back, and then motor information goes out the front. Right? I always say in the back door, out the front door, like that. Okay, so that's what would be in these roots. This would be sensory fibers going in. This would be motor fibers going out. Now, once the spinal nerve is formed, it leaves the intervertebral foramen of the vertebrae, and then it's going to branch into actually 4 branches. I'm going to focus really on the main 2 branches and just kind of mention the third. The fourth one I'm not too concerned about. So when the spinal nerve emerges from the intervertebral foramen, like right about at this level, notice, guys, there's a small branch that's going to bring both sensory and motor fibers towards the back of the body. Remember, this is the spinous process. So over here would be like muscles of your back, right? The muscles of your back would be over here. Your skin would be, out on your surface over here. This is going to be called the posterior ramus. A ramus is a branch. So this is a branch of the spinal nerve. This one's going to go to the back of the body. You can see it's kind of thin and small. This bigger branch is the anterior ramus. So this would do this. If you look at me for a minute, it would come from the intervertebral foramen and then come around the front of your body, like the lateral wall of your chest, to the front of your chest. And then these are also the nerves that are going to form and go into your upper limb and your lower limb. So that's one of the reasons this is a little bit bigger, the anterior ramus, just because it's supplying more of the body. The posterior ramus is just going to the back of our neck, back between our shoulder blades to our low back, all of that type of thing. So these are the two main rami that I want you to know, the anterior ramus and the posterior ramus. This structure here, I don't have it labeled. This is called the rami communicantes. This is going to receive, if you remember, watch this. Remember here, this was the lateral horn, and the visceral efferents came out like this. And we said that they're going to go to the organs. The way they head to the organs is they're going to go into here, and then head to an organ from here. So this is known as the rami communicantes, right? Since I have it in the notes, that's what it means. I didn't label that. I'm not too concerned about that right now. What I'd like you to really know is the anterior ramus and the posterior ramus. Okay. The last thing about the spinal nerve is this. Our spinal nerves are covered by connective tissue. If we were to pick up a spinal nerve, let's say your sciatic nerve, right? We were just, my pen here is a sciatic nerve, let's say. The connective tissue covering around the entire sciatic nerve in this case would be called the epineurium. Okay, so that's the deep fascia that surrounds the entire nerve. Then if we were to cut the nerve in half, we would see bundles of axons. Each bundle is called the fascicle, and the fascicle is surrounded by the perineurium. Then each individual axon inside the nerve, inside the fascicle, I should say, has its own connective tissue covering called the endoneurium. The endoneurium. So if we take a look over here, they took a nerve, right? And this connective tissue around the entire nerve is the epineurium. Then you can see there are bundles of axons. So all of these bundles here contain axons in it. The bundle is surrounded by perineurium. So what I like about this picture is they pulled out one of the fascicles, the bundle, and all of this purple connective tissue is the perineurium right there. Then they pulled out an axon, right? You can see here it's like the Schwann cell. Here's the axon. Then you can see right here this connective tissue over the Schwann cell would be the endoneurium. So if you remember, we actually did something similar to this when we looked at muscle tissue, right? Remember we had the epimysium surrounding the entire muscle, and then the perimysium surrounding the fascicles, and the endomysium surrounding the individual muscle fibers. It's the same thing. We're just changing the name from mysium to neurium, right? From mysium to neurium. Okay, so that concludes this lesson on how the spinal nerves are formed and coming from the spinal cord.